Let's go ahead and continue this section with the steps for graphing polynomials. So as a reminder from the last video, end behavior is going to be very important when you're looking at polynomial graphs. So these 4 steps that I've come up with are going to hopefully help you graph polynomials as easily as possible, and just know that these are going to be rough sketches of these graphs. They're not going to be exact. The 4 steps I have for you are listed here, and I would definitely write these down, put them in your notes so you can refer back to them. They are to first determine the end behavior of a graph, and remember that's determined by the degree and the leading coefficient. And then step 2 says to find the max number of turns. In order to do that, what you need to do is take the degree and subtract 1. For example, if a degree is 4, then that means the maximum number of turns it could have would be 3. Keep in mind that just because the max number of turns is 3 doesn't mean it's going to have exactly 3. It was going to vary depending on the equation that you're given. Next step is to find the y-intercept, and the easiest way to do that is just to plug in 0, because remember, any point on the y-axis is going to have an x that is equal to 0. And then lastly, which I would say is the longest part, is just making a table. So you're going to pick positive and negative values, maybe even some fractions, plug them into your equation, and plot the points. And remember, there's not going to be any set amount of points I'm going to tell you that you have to have, because every graph is going to be a little bit different. But the more points that you plug into your equation, the more accurate your graph is going to be, and hopefully the better shape you're going to get out of it. So let's go ahead and do one example together, and then I'll give you an example that you can try on your own. And if you need some extra help or extra practice with it, just let me know and we can do more in class. The first example I'm going to give you is this equation: f of x equals x cubed minus 4x squared minus x plus 3, 2x plus 3, sorry. So remember, the first step we said is to determine the end behavior. The end behavior is determined by the degree, which in this case is the highest exponent of 3, and the leading coefficient. Now this leading coefficient is a 1, and notice that it is positive. So we have an odd degree with a positive leading coefficient. That means our end behavior is going to go up to the right and down on the left. And if you don't remember where I got that from, look back in the previous video. We had the 4 different types of end behavior. What this means for our graph is that the further I go to the right with my x values, the further up it's going to go. And the more negative values I pick for my graph, the further down it's going to go forever. So when I graph these, what you might notice is that your graph's going to shoot up really quickly and down really quickly as you go further right and further left. Step 2 is to determine the max number of turns. So here our degree was 3. So that means the max amount of turns we could have would be 2. So when you connect your graph, if you have more than 2 turns in your graph, then that means there's something wrong with the points that you've got. All right, so that's a really useful tool in order to figure out where to connect your points and what it should look like. And then step 3, we said, was to find the y-intercept. Now remember, we said to do that, you're just going to plug in x equals 0. So when I plug 0 into this equation at the top, I'm going to do that up here. 0 to the third is 0. Minus 4 times 0 squared is still 0. And then minus 2 times 0, and then plus 3. And remember, all these zeros, they're going to cancel out, and I'm just going to be left with a positive 3. So here's my first point of the graph, my y-intercept at 0, 3. The fourth and final step is where you make your table of values and then plot the points and connect the graphs. So I've already gone ahead and created the table of values just to save time, but obviously you're going to be picking numbers, positives and negatives, to plug into your equation, and then you'll have to plot them. Now, which numbers you choose will be up to you. You'll hopefully notice a pattern as you start to plug in numbers, and one thing I'm going to encourage you to do is to adjust your table accordingly. So you might start with only 5 points that you plug in, but maybe you don't have enough after those 5 points to really tell what your graph looks like, and you might have to plug in more. So you're going to have to kind of play it by ear when you graph. The more points you have, the more accurate your graph is going to typically be. So it never hurts to have quite a few points in a table. So I'm going to go ahead and show you what I have in my table, and then we're going to plot these really quick, and then I'll give you the one to try on your own. So here's my table of values. I'll go ahead and move it up so you guys can see it. So I went ahead and plugged in numbers 1 through 5, and then I plugged in just a couple negative numbers because my numbers dropped pretty quickly when I plugged in the negatives, so I didn't need a whole bunch of extras. I'm going to go ahead and plot those real quick on here just so we can see what this graph looks like. So I've got 1, -2. I've got 2, -9, so that's down here. 3, -12, so that's actually off my grid. And then notice that at 4, my graph starts to come back up. So 1, 2, 3, 4, 5, up to -5, which is good. If you look at my end behavior, it said to the right side of my graph, it should eventually be going up. And the left side should be going down. So when I graph this, my points on the right side eventually should be going up to positive infinity. And then even up at 5, it goes way up to positive 18, way off my grid. The negative numbers, when I plot those, I get -1, 0. Now notice I plugged in -1.5. That's because I realized that when I plugged -2, my graph dropped really low down here. And so I wanted an extra point that was a little bit further between them so that I could connect my graph a little bit more accurately. So I plugged in -1.5, and I got that -6.4. So keep in mind that you might not always have nice numbers when you plug these things in. If you get decimals, just estimate it on your graph as best you can, and it should be good to go. So now I've got my points here, and now I just need to go ahead and connect my graph. So I'm going to start at the bottom. It doesn't really matter where you start, but I'm going to start from my furthest left. I'm going to follow my points up to the next ones where it hits at 0, and then I'm going to hit my y-intercept. But then I have to get down to this point. So here I'm going to have a turn, and it's going to start going down to follow these points. And then now I need to go back up. So here's another turn in my graph, and then all the way up to the top. So I plugged in these points. I've got my graph here. Make sure it matches the end behavior that you stated in step 1, which mine does. It goes up on the right and down on the left. And if you look at my max number of turns, the max I said it could turn was twice. Well, here's 2 turns. I've got the top turn here and then the bottom one here. Those points also we call our local max and our local minimum. And the reason they call them local is because you could have more than one, and also you don't want to call it a max value because technically this graph goes forever in both directions. So it actually goes up and up and up all the way to infinity. So instead we're just talking about one particular high point of the graph or a particular low point. And a graph can have multiple maximums or multiple minimums depending on the number of turns it has. So that's something really important to look for on a graph. So if you have any questions on this, make sure you write yourself a note, ask me in class. But here's an extra practice problem for you guys. Try it on your own, and if you need me to check it, I will gladly do that. That's it for today. Thanks for listening.